Let us learn more about parallelograms. We have a parallelogram here ABCD, wherein the opposite sides, the pairs of opposite sides are parallel to one another. This is the basic definition of a parallelogram. So we have AB parallel to DC, and also we do have AD parallel to BC. Now, in our previous video, we saw that when one diagonal was drawn across the parallelogram, that is connecting the non-adjacent sides of the parallelogram, diagonal AC, it divides it into two congruent triangles. Now here, let me draw the second diagonal also. So any four vertices, any figure with four vertices would have two diagonals, right? So there are two diagonals here, AC and BD. So let them intersect at O. Let AC and BD intersect at O. So what do we have? We have four triangles here. Four triangles, and let's explore about these two triangles which are placed opposite to one another, triangle AOB and triangle COD. So in these two triangles, since we have two of its sides, that is the side AB of the triangle AOB and the side CD of the triangle COD are equal to one another. Why is it so? Because it's a parallelogram, the opposite sides are equal. So these two sides are equal. And what else do we observe in these two triangles? AB being parallel to DC, and if we consider AC as the transversal, if AC is considered as the transversal, then we do have these two angles, the alternate interior angles formed when AB is parallel to DC. These two angles are equal to one another, the alternate interior angles. And similarly, the angles which I am marking in brown here are also equal to one another. This is also the other, when BD is considered as the transversal, these two angles also are equal to one another. So let me put my observation down in words here. I have angle DCO, right? Angle DCO is equal to angle OAB, right? DCO OAB. So this is my first observation, the green angles. And now what about the other two interior angles when BD is the transversal? We have angle, the angles in brown, CDO, right? The angle CDO is equal to angle ABO. Am I right? Yes, it's ABO. So we have two sets of angles also equal, and one side is equal to one another in these two triangles AOB and COD. So we can conclude by the AAS congruency criteria, that is two angles and one side equal, these two triangles are congruent to one another. Triangle AOB and triangle COD are congruent. And why is this important? Why is this result important? It's just important because of the corresponding parts of congruent triangles, which is these two parts now. The important parts which we need to observe is these two lines or line segments are equal to one another, and similarly in these two triangles you can say that OD and OB are also equal to one another, which is I have AO is equal to OC and also OD is equal to OB. What does this state? This says the very important result or the very important property of a parallelogram. The diagonals of a parallelogram bisect each other. The diagonals of any parallelogram bisect each other, divides each other equally. This is equal to OA is equal to OC, and this diagonal is divided, is bisected by the other diagonal BD, and similarly BD is also divided equally into two halves by AC. So this is one important property of any parallelogram. And now in our next video, let's explore if the converse of this theorem, whether the converse of this theorem is also true. What would be the converse? If we are given that in any four-sided figure or in any quadrilateral, if the diagonals bisect each other, then can we prove whether that quadrilateral is a parallelogram? So this is the converse, and we'll try to prove the converse in our next video. Thank you.